Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
During operation, a mixture of oil vapor, gasoline, exhaust gases, and water vapor creates increased pressure in the crankcase space. If this rattling mixture is not vented, the pressure will not only interfere with the removal of oil from the cylinder walls, but also squeeze out the crankshaft and camshaft oil seals. The device of the system. The specifics of the device and the principle of operation of the system depends on the specific engine model. But the typical design involves the presence of a crankcase ventilation valve, pipes, and an oil separator. Principle of operation: exhaust gases mixed with gasoline vapors, due to the pressure formed, flow to the oil separator. In the oil separator housing, finely dispersed oil particles are collected on the walls of the filter element. The resulting droplets are drained by gravity into the oil pan, and the filtered gases flow through the crankcase ventilation valve into the intake manifold. The design of the above system assumes the presence of an intercooler which serves to cool the air flow. The need to reduce the temperature is not so much due to the crankcase ventilation, but rather due to the peculiarities of the turbocharging system, which is equipped with the TDI engine shown in the diagram. Now about flow separation. Standard crankcase ventilation system has two pipes of gas supply to the intake tract. It is connected with the difference of pressure before the throttle and in the throttle space. In the minimum load mode, when the throttle is barely open, the passage cross-section is minimal, so the greatest rarefaction is just in the throttle space. At high and full load, the open throttle does not create significant resistance to the flow of air, so the vacuum in the intake tract is minimal. Separation of the inlet points allows flexible dosing of the crankcase gas portion. The labyrinth method acts as a coarse filtration stage and serves to separate large oil particles. The principle of operation of the catcher is to pass the crankcase gas flow through a channel with oil deflector plates. On contact with the plates, coarse particles settle on the walls and then flow into the return oil line. At the stage of fine cleaning, crankcase gases pass through a cyclic, centrifugal, oil separator. The principle of operation is based on the passage of gases around the circumference of the separator body. Under the influence of centrifugal forces, oil droplets, whose mass is greater than the mass of the exhaust gases, are displaced outward and settle on the wall. After separation, the smallest oil particles flow into the return line. To reduce the harmful effect of turbulence of gas streams at the inlet to the air path, the device of this type of system assumes the presence of an outlet stilling chamber. Thanks to it, after passing the centrifugal oil separator, the kinetic energy of the gas is reduced. In addition, fine particles of engine oil also settle on the chamber walls. Some crankcase ventilation systems use a synthetic filter element. As crankcase gases pass through it, oil particles settle on the fibers, collect in large droplets, and flow into the return drain line. PCV valve. The crankcase gas ventilation valve is necessary to limit the discharge. High vacuum, as well as overpressure, can cause damage to the oil seals. Therefore, the PCV valve allows access to crankcase gases as the vacuum in the intake manifold drops. In normal operation, the valve is held open by a return spring. When the engine is running at idle speed, the vacuum overcomes the spring force and closes the channel between the engine crankcase and the intake manifold. Accordingly, as the throttle is opened and the vacuum decreases, the return spring opens the channel to allow gases to enter. On many VAG vehicles with a two-stage filtration system, the operation of the PCV valve is to interrupt the flow from the coarse stage to the fine stage. Symptoms of malfunction. Signs of improper operation of the crankcase ventilation: increased oil consumption, heavy sweating in the places of installation of glands, cylinder head gasket, BC, oil pan. As the engine cylinder piston group wears out, the amount of gases bursting into the crankcase increases, so the load on the system increases. but the symptoms of increased pressure in the crankcase can manifest themselves and on a serviceable car. In the frosty season, condensate accumulates in the pipes of the system, which, when freezing, completely blocks crankcase ventilation. From damage to the oil seals, often in this case, the dipstick is saved, which is squeezed out of the seat. The engine trots, revs float. The reason is a leaky valve or a line from the valve to the intake manifold, due to which there is an intake of unaccounted air. Motor oil in the air filter, intake pipe. The cause is a clogged filter element. In conclusion, understanding the features and operation of the crankcase ventilation system is essential for maintaining engine performance and longevity. We explored the principles behind the positive crankcase ventilation valve, its critical role in managing crankcase gases, and the common malfunctions that can occur. By learning how to check and diagnose this system, you can prevent potential issues that may lead to costly repairs. Regular maintenance and awareness of these components will ensure your engine runs smoothly and efficiently. Thank you for watching, and be sure to stay tuned for more insights on automotive systems.